All right, so you didn't have that many. So it was 1, 3, 11, 16, and 17. So I'm going to do them here on this side. Maybe if I move that. Okay, so number 1 is I put it in your homeroom class. And I hanged it up in your closet. Okay, no problem. All right, so where are we? Number 1. So number 1 is 6r. So hopefully I have room. Plus 7 equals 13 plus 7r. So let's go through the steps, right? Step 1, do you see distributive property? Do you have to distributive property? And one way you can check for that is look for parentheses, and there are none. So 1 is gone. 2, combine like terms. And let me split this equation into 2 parts. Look here. Can I combine these 2? I cannot because they're not like terms. Can I combine these 2? No, I cannot. So that's 2. 3, are there variables on both sides? Yes, of the equation. So there's a 6r here and the 7r over here. So one of them have to go. My suggestion to you in class was always get rid of the smaller one because then you don't have to deal with negatives. So we're going to get the 6r, we're going to throw it out. But how do we show that we're throwing the 6r here? Well, that's a positive 6r. In order to get rid of it, if I put minus 6r under it and then combine those two, what's 6r minus 6r? That equals 0. Right? And that's how I get rid of that 6r. So let me just, but if I do minus 6r on this side of the equation, I have to do minus 6r on this side of the equation. So I'm going to do that as well. Okay, so that's your first step. Now, as I just mentioned, 6r and minus 6r becomes 0, and then plus 7 comes out. That you'll notice now, do I really need to write 0 or even the plus sign? No, so we're just going to write 7. On this side, well, the 13 is combining with no 1, so I bring it down. And then 7r minus 6r is just positive 1r. But, write 1r, we don't have to, we just write r. If you like to write the 1 on top, you may. Now this becomes a very simple equation. So here's my variable, r, right? What's happening to it? I'm not multiplying. Well, it's multiplying by 1, but we're not going to write that. But is it multiplying by any other coefficient besides 1? No. But we're adding 13 to that. And somehow it's giving me 7. So what's the one inverse operation that I have to do? I'm going to subtract 13 from both sides. So let me make a line again. And then I want to get rid of the 13. And to get rid of that positive 13, I'm going to do minus 13 at the bottom and then minus 13 over here. 13 and minus 13 is r. 7 minus 13 is going to be negative 6. So r is negative 6. That's what I think it is. Right? So I'm going to go back to the equation. Right? 6, let me write this. I'm going to leave a little space there. So everywhere I see the letter r, I'm going to replace it with negative 6, and I'm going to put it over here. Negative 6, parentheses, I'm going to put times negative 6. Take your calculators if you like, and you're going to tell me if the left side equals the right side. Does it? 6 times negative 6 is negative 36, plus 7. And on this side we got 13, and 7 times negative 6, so plus negative 42. So this equals to, am I forgetting something here? Oh, this is a plus 7, sorry. And that's going to give me negative 29. And on this side, it's also going to give me negative 29. So because the left side of my equation equals to my right side of the equation, when I plugged in negative 6, I know my answer r equals negative 6 is correct. Let's do number 3. Just copy it. Negative 7x minus 3x plus 2 equals negative 8x minus 8. That's my step 1, distributive property. Do you see any parentheses? No. So I don't have to do the distributive property to get rid of them. 2, Combine like terms. Let me make a line right here. Negative, can I combine anything? Well, if you look at the left side, I have these two, right? Actually, you know what? I'm going to circle them. Negative 7x and negative 3x are of the same kind, right? I can combine those two. So negative 3x and negative 7x and negative 3x is negative 10x. And then plus 2. On the right side, negative 8x minus 8 cannot be combined because they're not like terms, so just leave it like that. So I did, there was no distributive property. There was combined like terms, a little bit on the left side. Now I look at the variables. I check if there are variables on both sides, and there is. There's negative 10x on this side and negative 8x on that side. So I need to get rid of one of them. So who is the smaller? Right, so if you look at the number line, let me draw a number line right here. The 0, negative 8 would be here, and negative 10. So between negative 10 and negative 8, who's the smaller one? Negative 10. And that's who we're going to get rid of. That's negative 10x, and in order to get rid of that, if I add plus 10x, look what happens. Negative 10x and plus 10x becomes 0. So they get eliminated. Okay, so let me take that out for now. But if I add 10x on this side, I'm going to add 10x to the other side. Now let's do it. Negative 10x plus 10x, like we said, becomes 0. And we bring positive 2 down. There's your positive 2. Negative 8x plus 10x is 2x. And then minus 8. Make a little story here. Here's my variable x. It's being multiplied by 2. Subtract 8. And that somehow gave me 2. The inverse operation I'm going to use is plus 8. And then divide by 2. So now we get to do it. Plus 8 over here. And if I do plus 8, notice that minus 8 and plus 8 is going to become 0, right? But I have to do plus 8 on this side. So minus 8 plus 8 go away because it's 0. The only thing left over is 2x. On the left side, 2 plus 8 is 10. So I just did that. Now the second thing I have to do is divide by 2. That's what it says here. So I'm going to show me division. So divide by 2 and divide this by 2. 2 divided by 2 is 1. 1 times x is just x. And 10 divided by 2 is 5. So apparently the answer is 5. But we have to do the check. So everywhere I see the x, I'm going to put a 5. So let me just write everything here. And I'm going to write the x here, right? 5. I'm going to put that times 5. Negative 3 times 5. Plus 2 and 10 equals negative 8 times 5. So everywhere I saw the x, I'm putting the 5. So if you have a calculator, go ahead and do it. Let me do the right side because that's easy. Negative 8 times 5 is negative 40, and negative 40 minus 8 is negative 48. So I hope that whatever we get here on the left side, it also adds up to negative 48. 7 times negative, it's like negative 5 times 7 is negative 35. Minus 15 plus 2. Negative 35 minus 15 is negative 50 plus 2. And negative 50 plus 2 is negative 48. So we are good. I know it's a lot, but I don't think it's nothing you cannot do. 11. 11 was negative 8n plus 4, 1 plus 5n equals negative 6n minus 14. Okay. I'll just move this guy to Is there parentheses? And if there are, you have to do the distributive property. No choice. So distributive property is going to happen here, right? The factor that's right outside the parentheses is going to multiply everybody inside by 4. So the negative 8 does nothing. So I'm going to keep it in blue. But the 4 is going to multiply 1, and they're both positives. 4 times 1 is just positive 4. And positive 4 and positive 5 is going to give me 20. Equals, on the other side, negative 6n minus 14. So distributive property, check. Step 2, can I combine like terms? So look on the left side. Well, this guy over here and this guy over here can be combined. Negative 8n plus 20n can be combined, and you get 12n. And then the plus 4. On the right side, these two cannot combine, so leave them alone. Step 3, look at the variables and see if there's a variable on both sides. Look, there's a 12n on the left side and negative 6n on the right side. So one of them has to go, and we said that we want to get rid of the guy who's further to the left on the number line. Negative 6 is further to the left. So minus 6n or negative 6n, and the opposite of that is plus 6n. Notice that if I combine these two, it becomes 0, and that's what I want, right? On the other side, I'm going to write plus 6n as well. So let's take care of this. 12n plus 6n, 18n, plus 4 comes down. Negative 6n plus 6n, these become 0, and then negative 14 comes down. On this corner right here, I'm going to do my little guide. I have a variable n. It's being multiplied by 18 and then add 4. And it equals to negative 14. So the first inverse operation I'm going to do would be minus 4 and then divide by 18. So let's do that. First thing first, minus 4 over here and minus 4 over here. 18n comes down. 4 minus 4 will be 0, so I don't need to write it. And then negative 14 minus 14 is negative 18. Step 2, we did step 1. Step 2 says divide by 18. So I'm going to take this guy and divide by 18. I'm going to take this guy and divide by 18. 18 divided by 18 becomes 1 and 1n. Here's my answer. And then negative 18 divided by 18 is negative 1. So my answer is negative 1. I need to see if it's correct. So again, go back to the original equation, and everywhere you see the letter n, you're going to replace it with negative 1. So let me write it. Negative 8 times n, and I'm just going to write it this way, plus 4, parentheses 1 plus 5 times negative 1, equals negative 6 times negative 1 minus 14. So everywhere there was, I'm going to highlight this and this and this. That's all the n's that I replaced with negative 1. So put in your calculator, see if it works. So on the right side, let me just do this. Negative 6 and negative 1 is negative positive 6 minus 14. And I get negative 8. So as long as your left side is also negative 8, we're good. Negative 8 times negative 1 is positive 8. Plus 4. Inside the parentheses, we have 5 times negative 1, which is negative 4. Negative 4 plus 1 is going to be negative 3. 8 plus negative 12, and I messed up already somewhere. Oh, sorry. My mistake was here. It's supposed to be a 4. 4 times negative 4 is negative 16, and then 8 plus negative 16 is negative 8. So is my left side equal my right side? Yes. So negative 1 was the correct answer. What number was that? 11. 13, no, 16. 38 plus 7k equals 8k plus 4. Is there a property? Yes, there is, so we have to take care of that first. So nothing happens until I get rid of the parentheses. 8 times k is just 8k, they're both positive, and then 8 times 4, they're both positive, so just plus 32. Superior property is gone. 2, let's look at the left side. Can I combine these two? No. Can I combine these two? No, so there's nothing to combine. Great. 3, check if there's variables on both sides, and there is. There's a 7k here and there's an 8k here. One of them have to go. Just to make life easier, let's get rid of the one that is the smaller one. So we're going to get rid of the 7k. That's a positive 7k. So the opposite, or the inverse operation here, that's going to give me 0. What can I add to plus 7k to give me a 0? Well, I have to add, in this case, I'm going to subtract minus 7k. Which I'm going to do the same on the other side. 38 comes down. 7k minus 7k is just 0, so we don't like a 0. 8k minus 7k is just 1k plus 32. So here's my little table. My variable is k. It's being multiplied by 1, which we don't have to write, and then we're adding 32. And that's going to give me 38. Inverse operation that we need to do to solve this equation is subtract 32 from both sides. So minus 32 on this side, minus 32 on this side. Those two will go away, k will come down, and 38 minus 32 is 6. So they're telling me that the answer, the value of k, is 6. When k equals 6, this equation becomes true. So let's go back to the original. And everywhere I see k, I'm going to replace it with 6. So we get 38 plus 7k plus 7 times 6 equals 8, and 6 plus 4. So let me highlight the k. So this was a k, so I changed it to 6. This was a k, I changed it to 6. Well, let's make sure we're good. Here, inside the parentheses, 6 plus 4 is 10, and then 10 times 8 is 80. On this side, we have 38 plus 7 times 6 is 42. Is 38 plus 42 80? Yes, it is. So our left side equals my right side, and k does make this equation true. K equals 6 makes the equation true. Last one, I believe, 17. Oh no, this one's a long one. 8x plus 4, 4x minus 3 equals 4. 6x plus 4 minus 4. There's everything in this equation. So step 1, distributive property. And let me make an arrow so I know where the distributive property is happening. Remember to be really careful with what kind of number you're multiplying. So 8x does absolutely nothing, just hangs out here. Let me change colors for distributive property. Plus, and then we have plus 4 and plus 4 inside. So 4 times 4 is positive 16. Don't forget the x. This is a 4 and this is a negative 3. So positive times a negative is a negative, and 4 times 3 is 12. Equals. Again, distributive property. They're both positive. 4 and 6 are positive. So it's going to give me 24x. And then that 4 with this 4 inside is going to give me 16, and they're both positive. Good. And then minus 4. Good. So all I did was remove the parentheses by doing the distributive property. 2. I want you to look at the left side and see if I can combine anything. And lucky for us, they're side by side. So 8x and 16x, they're exactly of the like terms, and we can combine. So that's 8x plus 16x, we get 24x. We're not going to combine it with the 12 because the 12 is not like terms, so that's good. On the right side, can I combine anything? Yes, again. This is a constant. This is a constant. They both can be combined. So we get 24x, and 16 minus 4 is plus 12. Ooh. It's going to be an interesting question. So now we do the distributive property. We combine like terms, and we got to get rid of one of the variables. So they're both the same, right? It doesn't matter which one. So let's get rid of this one. And this is positive 24x, and if I subtract 24x, it's going to give me a 0, so that's going to work, right? Because we want to get rid of it. But you will notice something special in here. 24x minus 24x is 0. That goes away, and I'm left with negative 12 here. 24x minus 24x is 0, but I'm left with positive 12. So that's saying negative 12, I can leave that as well. Negative 12 because positive 12. So first of all, look at that statement. Is negative 12 ever equal to positive 12? Ever. Because that's what that's saying. So if you ever come to a situation like this, there is no solution to this equation because there's no way negative 12 is ever going to equal to positive 12. That's one way of looking at it, and then I'm going to go back here a little bit. Back. Oh, you know what? I'm not. I'm going to give you a different example. So the answer is there's no solution, but I'm going to give you a different example. Let's take a look at this equation. X equals x. And let's say x equals 3. Well, let me plug it in. Well, if I substitute x with 3, I'm going to get 3 equals 3. Is that true? Yes. Let me plug it in with negative 3. X, replace x with negative 3 and x with negative 3 here. Is that true? Yes. Let's pick x equals, I don't know, x equals 245. Well, let's replace it here. 245, and then this is also 240. Is that true? Yes. Let's pick x equals 3/4. Right, I'm going to change it to a fraction. Well, so I'm going to replace here. This x was 3/4, and this guy was 3/4. Is that true? So you'll notice that doesn't matter what we replace x with, it's always going to be true. Well, because this is exactly the same as this. So if I say x equals 0.00825, well, let me take this. 0.00825, and this is x also, and this is 0.00825. It doesn't matter what x is, it will always equal each other. So in this case, the answer is all real numbers, because it doesn't matter what we replace x with, it will always work. Now, let me show you something that doesn't work, which is what we had here. So let me take the same example, x, and let me call this 3x. Right, and then you solve the problem, and you found the answer, and you say x equals 2. Well, let's see if it works. Well, I'm going to replace this guy with 2. And on this side, it's going to get 3, and then replace the x with 2. Well, are they going to be equal? No, because this is going to be 2, and this is going to be 6. Pick another number. Let's say x equals, I don't know, 25. Well, we're going to replace this x with 25. And on this side, it's going to be 3 times 25. Are they going to be equal? You can already tell that it's the answer is no. That's not going to work. So notice that here, one is x and the other is 3x. So there's no way this will ever equal to each other because they're not the same, right? One is x and the other one's 3 times the x. So in this case, there is no solution. That will never happen, which is what happened in the problem we just did. So let me write that over here. So we had a situation where let me go back here. It's a 24x minus 12 equals 24x plus 12. So if you notice, these two were the same. So let me take the 12s out. Let's write 24x equals 24x. So let's say x was 2. Right? If x was 2, this would be 24 times 2, and this would be 24 times 2, and they both equals 48. Everybody okay with that? Right? If x was 3, it'd be 24 times 3, and then on the other side 24 times 3, and you would get 72. So it doesn't matter what you put in for x in this scenario right here. Right? If that was the answer, or that's the equation you had, it would always be the same, and x, the solution would be any single number for x, because on the left side you're multiplying 24 times x, and on the right side you're also multiplying 24 times x. Right? So it doesn't matter what you plug in, it would be every single number. But there is a difference with what we got. On one side it says, hey, take 24, multiply by x, and then subtract 12. On the right side it says, take 24, multiply by x, and then add 12. So there's no way they would ever. So let's just try one. Let's say x was 2. Well, if x was 2, we get 24 times 2 minus 12. 24 times 2 is 48. Minus 12, we would get 36. Let's check the right side. Well, the right side starts the same way, 24 times x, which is 24 times 2. But instead of subtracting 2, we're adding 12. So here we get 48, and then plus 12, we get 60. So on one side is 24x, and the other side is 24x, but there's a slight difference because on the other one, we're subtracting 12, and on the right side is plus 12. So there is absolutely no way they will ever be equal to each other. So this is one where we already wrote that there is no solution. Okay?